let us talk about a graphical representation for our previous lecture. So let's present the building blocks. We got the input, and we know that the input is al minus 1, which in this case equaled x, and the output was al, which was the y hat, which was the output. And then if it wasn't an input and if it wasn't an output, then the activation function is presented in this form, where z is the weights and g here is whether you're using a sigmoid, a tanh, etc. So this was your forward propagation. Now let's look at the backward propagation. So the inputs for your backward propagation would be the DAL and the values for ZL, since you would need that to have your weights and real number. And the output would be your input features, basically. Your weights and your real numbers. And this was your backward propagation. So how do we present this? So let's get a clean slide here. We'll draw a box where the input is basically the input features, which is donated by al minus 1. You have initialized WL and BL by random variables, and the output of this would be, should find a way to freeze this, and the output would be AL. So if you had multiple neural networks, then the value of AL is going to go to the next one. So let's say in our case that will be L plus 1, B L plus 1, and then you get the activation L plus 1, and so on and so forth. And then when you come with the back propagation, you're gonna get the derivative of the activation function. We've shown the calculations of that in previous examples and lectures. You already have some weights that's been saved here, and you have the cache value, or you do have the value of ZL plus 1 from here, and this value will be needed. And when we write the code in Jupyter, we're gonna need this value, so it will be saved. And by having these values right here, we will be able to calculate the derivative DZL, DWL, and DBL. And this is important to get our back propagation. So if we look perhaps at previous slides, this is how we would calculate so the second layer minus y, and we get the value, and so on and so forth. So as we go back in the propagation, we want to see if we would change the y a little bit, what happens to the input feature. Is it getting closer or is it getting further away? So yeah, so this was just a simple way to present it away from all the equations.